Hello everyone, I am Priyanka Singh Chauhan and today I will be presenting on the topic Big Data Analytics in LinkedIn. We all use LinkedIn almost daily to connect, search for job or share updates, but behind the scenes, the platform processes billions of data points every single day. So today I will be explaining how LinkedIn uses big data to make our experience so smooth and personalized. To make it simple, we will move step by step. We will start with an introduction to big data, then move to LinkedIn's overview and its data sources and the big data architecture. After that, we will look at key applications, case studies, and the big data ecosystem that supports everything. Finally, I will talk about AI and personalization, tools and technology, and the end with challenges, strengths, and a conclusion. So exactly, what is big data? Big data refers to extremely large and complex data sets that are processed using traditional tools. To better understand it, let's explore the 5 V's of big data. With the example of LinkedIn, volume means the sheer size of the data. LinkedIn stores petabytes of user information. That's thousands of terabytes of resume, posts, connections, and job listing. Velocity refers to the speed at which data is created and analyzed. For instance, when someone likes your post or sends you a message, that event is processed and reflected instantly. Variety focuses on different types of data. LinkedIn handles text, images, videos, recruiter searches, resumes, and even skill endorsements. Veracity deals with the accuracy of data. LinkedIn constantly filters out fake accounts, spam content, and outdated job information to keep the system reliable. And finally, value. This is the purpose of all analytics. Data becomes valuable only when it creates insights like recommending a job, suggesting a course, or helping you to find the right connection. So big data is not only about the size, it's about deriving value from information. LinkedIn was launched in 2003 and today it has more than 1 billion users worldwide. It is not just a networking site, it is a professional ecosystem where people build their profiles, follow companies, learn skills, and apply for jobs. Every click, view, and interaction becomes part of LinkedIn's data network. This data is what helps LinkedIn personalize your experience and make relevant recommendations. LinkedIn gathers data from multiple sources: user profiles, engagement data, recruiter data, learning data, external data. Together, these sources create a huge pool of structured and unstructured data, which forms the backbone of LinkedIn's analytics. This slide shows the big data architecture at LinkedIn, how data flows from collection to insights. It all starts with data ingestion using Apache Kafka, which streams real-time user activity such as likes, profile views, and job clicks. Next comes storage, handled by Hadoop HDFS, which stores petabyte of data reliability across multiple servers. For processing, tools like Apache Spark and MapReduce perform heavy patch analytics, identifying patterns or training models. For instant results, LinkedIn uses SAMZA and Pinot for real-time analytics, powering features like who viewed your profile. Finally, machine learning pipelines use this process data to recommend jobs, suggest connection, or personalize your feedback. This architecture ensures LinkedIn can process billions of data points while keeping user experience fast and relevant. Now let's go deeper into how the data actually travels through LinkedIn's pipeline. As shown here, raw upstream data is first processed using tools like Spark and Hive, where it is cleaned and structured. Workflow managers like Azkaban coordinate these processes, ensuring everything runs smoothly on Hadoop clusters. Once processed, data sets are stored and accessed by different teams. Developers use DailyReader for technical data extraction, analysts use dashboard for summaries, and data analysts perform ad hoc queries for deeper exploration. So essentially, raw user action turn into insights that powers LinkedIn strategic and operational decisions. OLAP, Online Analytical Processing, which helps LinkedIn turn data into meaningful analytics. OLAP system instantly show job reviews by time, title or company and profile views by country or industry. The system powering this is Avatar, LinkedIn's scalable OLAP engine that allows quick real-time querying. So when you open your dashboard and check who viewed my profile, OLAP is the system that delivers those results within seconds. We can see some of the LinkedIn's core data products that depend heavily on big data. People you may know uses the social graph to recommend connections, processing over 120 billion relationships daily. Jobs you may be interested in contribute to nearly 50% of LinkedIn's engagement using ML and text analysis to recommend jobs. Skill endorsement maps members to their skills through Voldemort key value stores and assigning endorsement scores. News feed updates uses Hadoop for testing and personalizing what kind of content appears on your feed. So, how does all this come together in real life? People you may know helps expand your professional network using social graph analysis. Job recommendation match your skills, experience and goals with relevant openings in real time. The newsfeed ranking system ensures you updates that are meaningful to you, whether it's a colleague promotion or a post from your feed. Recruiter Insights give hiring managers analytical dashboard showing top candidates and hiring trends. And LinkedIn Learning uses big data to recommend personalized course that helps users grow in their career. Together, these applications make LinkedIn more interactive, intelligent, and user focused. Let's look at two examples that show how this works in action. People you may know process billions of interactions daily. It uses Bloom filters to reduce unnecessary computation and deliver quick, accurate connection suggestions. Job recommendations predict relevant jobs based on user profile and real-time behavior. For example, a data analyst in India might instantly see opening that matches their exact skill set. These case studies prove how big data analytics is at driving user engagement and growth. The ecosystem behind all of this includes powerful open source tools like Hadoop for distributed storage, Pig and Hive for querying and analytics, Azkaban for workflow management, Avro for data serialization, and Zookeeper for coordination. Data enters to Kafka and exits via Kafka and World mode, ensuring seamless integration between online and offline systems. Here is a closer look at some of the LinkedIn specialized tools built on top of Hadoop. Voldemort is a NoSQL key value storage system used for fast lookups and powering most of the LinkedIn's data access. Decomposer runs large matrix computation in Java for advanced analytics. White Elephant monitors Hadoop performance with dashboards and failure logs. Giraffe performs graph-based computations for social network analysis. Avatar, the OLAP engine for real-time queries. Kafka, the published subscribed system that tracks billions of daily events. Azkaban handles workflow scheduling and dependencies for data jobs. Together, these tools form LinkedIn's big data backbone. This is the pictorial representation of what we studied in the previous slide, the big data ecosystem in LinkedIn. Hadoop, Zookeeper, Pig, Hive, Apache Kafka and World Mode, Azkaban, Avro Data, White Elephant, Avatar. Artificial intelligence adds intelligence to all of this data. AI helps rank your feed, filter spam, recommend jobs, and even detect fake profiles. Large language models helps match your profile with job description, while AI-driven systems anonymize sensitive data to reduce bias. The result is a platform that feels tailor-made for every user, aligning learning, career, and networking suggestions with personal goals. The tools and technologies alongside AI, LinkedIn's data stack uses some of the most advanced tools available today. Hadoop for long-term storage, Spark for both batch and real-time analytics, Kafka for continuous data streaming, Samza and Pinot for low latency real-time queries, and Graph Database for mapping complex relationships in LinkedIn's network. These technology ensure speed, scalability, and accuracy in every LinkedIn feature. Managing big data on this scale comes with challenges. Scalability, handling exabytes of data efficiently, real-time processing, managing millions of interactions every second, data privacy and security. LinkedIn must comply with GDPR, General Data Protection Regulation, a European law giving users full control over their personal data. Algorithmic bias. AI models can reflect human bias, so LinkedIn constantly audits its algorithm to ensure fairness. These challenges push LinkedIn to innovate continuously, not only technically but ethically too. The future trends looking forward. AI-driven career and skill recommendation, integrating with AR and metaverse networking, better fraud detection, and predictive analytics for forecasting future job trends. The next phase of LinkedIn will focus on predictive and immersive professional experience. Big data analytics is truly the backbone of LinkedIn. It powers everything from personalization and job recommendation to learning and recruitment. By transforming raw data into meaningful insights, LinkedIn has redefined how professionals connect and grow. Thank you for listening. I am Priyangi Singh Chauhan, and I hope this presentation helped you understand how LinkedIn uses big data to create big opportunities.